For decades, the battlefield was a game of brute force. Heavy metal, massive shells, and thousands of lives lost for just a few inches of mud. Traditional artillery was once the undisputed king of battle, but it came with a fatal price. These massive howitzers are slow to move, agonizingly loud, and in the age of modern counter-battery radar, they are often a death sentence for the crews operating them. One shot, and the enemy knows exactly where you are before your shell even hits the ground. But today, the challenge has evolved into something far more daunting. Imagine a high-value target, a massive ammunition depot, or a hidden command center tucked away 50 miles behind the front lines. It is shielded by a dense, suffocating web of advanced S-300 and S-400 air defense systems. To hit a target like this with conventional guns is a suicide mission. You would have to move an entire artillery division deep into the kill zone just to get within range. And a cruise missile? That is a multi-million-dollar gamble, a high-stakes play that can be detected and swatted out of the sky long before it ever reaches its destination. It was an unbreakable deadlock, an invisible wall that seemed impossible to breach until now. What if there was a weapon that could strike with the surgical precision of a sniper, but with the devastating power of a heavy bomber? A mobile ghost that appears from the shadows of a forest, delivers a lethal payload in seconds, and vanishes before the enemy radar can even lock on. To the soldiers on the receiving end, it is a nightmare to the world. It is the reign of tyrants. This isn't just another rocket launcher. It is a technological masterpiece that has single-handedly rewritten the rules of 21st century warfare. More details all in the video ahead. To understand how this ghost operates, we have to step into the darkness where the eyes of the enemy cannot reach. It is 3 a.m., somewhere deep within a thick, ancient forest, miles away from the nearest paved road. A shadow is moving. There are no headlights, no loud radio chatter. Just the low, muffled hum of a diesel engine and the crunch of tires on damp earth. This is the high-mobility artillery rocket system, but to the three men inside, it is simply their ticket home. Unlike the massive artillery batteries of the past that required dozens of soldiers and hours of preparation, this entire operation relies on just 3 individuals: driver, a gunner, and a launcher chief. They work in absolute secrecy, their movements a meticulously planned dance that has been rehearsed until it became second nature. There is no room for error. In this environment, a single mistake isn't just a tactical failure, it is a beacon that invites a rain of counter-battery fire. The vehicle comes to a sudden, tactical halt in a small clearing. The silence of the forest returns, but only for a heartbeat. This is the beginning of the most critical 5 minutes of the mission. Every second is a calculated risk. As soon as the wheels stop turning, the first stage of the deployment begins. Inside the cramped, green-lit cabin, the air is thick with focus. The launcher chief monitors the tactical data link, waiting for the digital handshake. High above, hidden in the vacuum of space, a network of military-grade satellites is already communicating with the vehicle's onboard computer. This isn't like the GPS on your smartphone. This is an encrypted, high-precision feed that provides coordinates accurate to within a few meters. Outside, the machine begins its transformation. Large hydraulic stabilizers known as jacks extend from the sides of the truck. You can hear the hiss of the pressurized fluid as they bite into the soft forest floor, leveling the massive vehicle and creating a rock-solid platform. This is essential. Even a fraction of a degree of tilt would send a rocket miles off course at long range. Then comes the centerpiece of the operation, the launch pod. With a mechanical whine, the massive rectangular box on the back of the truck begins to tilt upward, pointing its nose toward the stars. To an outside observer, it looks like a predator waking up. There's no guesswork here. The fire control system has already calculated the exact trajectory, factoring in wind speed, air density, and the rotation of the Earth itself. The tension in the cabin reaches a breaking point. The gunner's finger hovers over the fire button. They are now hot. They are a massive thermal signature on any overhead infrared satellite, glowing target in the middle of a cold forest. They have exactly 30 seconds to deliver the blow. The command is given. In a violent explosion of light and sound, the first rocket ignites. The sheer force of the launch shakes the entire forest, a massive plume of white smoke and orange flame illuminating the trees for miles. Then the second follows, then the third. In just under 30 seconds, all 6 rockets have cleared the pod, screaming into the upper atmosphere at Mach 2.5. The roar is deafening, a physical wall of sound that vibrates in your chest. But as the final rocket leaves the rail, the dance isn't over. In fact, the most dangerous part is just beginning. This is what military strategists call the shoot and scoot, and it is the reason the HIMARS is so feared. The moment the last pod is empty, the hydraulics are already retracting. The launch pod is folding back down into its travel position, even as the smoke from the first launch is still hanging in the air. There is no waiting around to see if they hit the target. There is no celebration. The driver slams the vehicle into gear, and the 5-ton truck roars back to life, disappearing into the thick canopy of the forest. 2 minutes, that is all it took from the moment they stopped to the moment they vanished. Now consider the perspective of the enemy. Miles away, their counter-battery radar has picked up the launch. They have tracked the trajectory of the rockets and calculated the exact point of origin. They scramble their own artillery or a drone strike to that specific clearing in the woods. They fire back with everything they have, desperate to destroy the ghost that just dealt them a lethal blow. But when their shells finally impact, they hit nothing but charred grass and empty space. The HIMARS is already miles away, hidden under a different patch of trees, perhaps already receiving a new set of coordinates for its next strike. It is an unprecedented fusion of domestic infiltration and high-precision aerial strikes, delivered in a single synchronized blow. This wasn't just another isolated attack, it was a ghost story brought to life. But what exactly is happening inside those 6 rockets as they scream toward their destination at 2.5 times the speed of sound? To understand why this weapon is so decisive, we have to look past the smoke and the fire and dive deep into the mechanical heart of the machine itself. We have to look at the power of the numbers. To truly appreciate the ghost, we have to look past the smoke and the fire and peer into the cold, mechanical heart of the machine itself. We have to understand the why. Why is this weapon so much more terrifying than a standard artillery shell? The answer doesn't lie in how much gunpowder it carries. It lies in the sheer, overwhelming power of the numbers. When a standard 155mm howitzer fires, it's essentially a giant physics problem involving gravity and wind. You point the barrel, you calculate the arc, and you pray the wind doesn't shift 10 miles up. If you want to destroy a single building, you might have to fire 50 shells just to land one on the roof. It's called carpet bombing or area saturation, and in the modern world, it's a blunt instrument. It's messy, it's inefficient, and it gives the enemy way too much time to react. The HIMARS, specifically the M31 Guided Multiple Launch Rocket System, or GMLRS, is something entirely different. It's not a blunt instrument, it's a scalpel. To understand how it achieves this, let's perform a digital autopsy on a single rocket, broken down into 5 distinct steps of lethal elegance. Step 1, the brain. Inside the nose of every M31 rocket is a dual-layered guidance system. First, there is the military-grade GPS receiver, which is constantly talking to a constellation of satellites to know its exact position in 3D space, down to the centimeter. But GPS can be jammed. That's why there is a second layer, the Inertial Measurement Unit, or IMU. This is a series of incredibly sensitive sensors, gyroscopes and accelerometers, that track every tiny movement of the rocket from the millisecond it leaves the launch rail. It effectively remembers its starting point and calculates its position based on its own motion. This internal map is so precise that even if the GPS signal is completely cut off, the rocket will still find its way home. Step 2, the muscles. As the rocket screams through the upper atmosphere, it isn't just falling, it's flying. At the very front of the rocket, just behind the guidance section, are 4 small, triangular fins called canards. At Mach 2.5, the air becomes as thick as water, and these canards move with lightning speed, making micro-adjustments hundreds of times per second. If a gust of wind tries to push the rocket off course, the canards twitch, banking the rocket back onto its digital flight path. It is a violent, high-speed correction that ensures the rocket stays locked on its target like a heat-seeking predator. Step 3, the heart. To get to a target 80 kilometers away in just a few minutes, you need a massive amount of energy. The midsection of the rocket is essentially a giant tube filled with high-energy solid rocket fuel. This isn't liquid gasoline, it's a stable, rubbery compound that burns with incredible intensity. Upon ignition, it generates enough thrust to propel the 600-pound rocket to over 2.5 times the speed of sound. At these speeds, the friction with the air heats the nose cone to temperatures that would melt lead, but the rocket is designed to withstand the thermal stress just long enough to deliver its payload. Step 4, the intelligence. Just before the rocket reaches its destination, the fuse system activates. This isn't just a simple hit and explode mechanism. The M31 utilizes a sophisticated multi-mode fuse that the crew can program before the launch. If the target is a soft vehicle, the rocket can be set to detonate a few meters above the ground for maximum coverage. If the target is a reinforced bunker, the fuse can be set to delay, allowing the rocket's hardened nose to punch through layers of concrete and steel before the warhead ignites inside the structure. It's the difference between a slap and a piercing needle. Step 5, the execution. Finally, we reach the warhead itself. This is where the physics of destruction becomes truly staggering. The M31 carries about 200 pounds of high explosives, but it's what surrounds that explosive that makes it a reign of tyrants. In the specialized alternative warhead version, the explosive core is wrapped in 182,000 preformed tungsten fragments. Tungsten, also known as wolfram, was one of the densest materials on Earth, almost twice as heavy as lead. When the warhead detonates, these fragments are blasted outward at thousands of feet per second. It's not just a blast wave, it's a cloud of 182,000 lethal pellets that shred everything in their path. A single rocket can effectively clear an area the size of an entire football field. Now, let's put these numbers into a perspective you can actually visualize. Imagine you're standing in the middle of a football stadium and someone is standing on a balcony 50 miles away. Traditional artillery is like that person trying to hit you by throwing a bucket of thousands of golf balls all at once, hoping one of them eventually bounces off your head. HIMARS is like that person taking a single orange, aiming it, and throwing it so accurately that it flies 50 miles and lands right in the palm of your hand. That is the level of surgical logic we are talking about. We are talking about a circular error probable of less than 5 meters. 5 meters after traveling 80,000 meters. Think about the sheer technical superiority required to achieve that. Every single button press on a HIMARS launcher is a high-stakes calculation involving millions of dollars in technology and decades of engineering. It's why a single vehicle operated by just 3 people can do more damage to an enemy's logistics than an entire regiment of old-school tanks. It's why, in the modern theater of war, the side with the best numbers usually wins. But the most incredible part of this story isn't just the rockets or the satellites. It's the fact that this entire complex, world-changing system is operated by real people in the most high-pressure environments imaginable. It's a human story as much as a mechanical one. And that brings us to the final piece of the puzzle. Why do we spend so much time obsessing over these machines? Why does this matter to you? Let's take a look behind the curtain. So, when you see those 6 rockets arc across the night sky, remember that you aren't just looking at a piece of artillery. You're looking at the ultimate fusion of global satellite intelligence and near-perfect mechanical engineering. It's a weapon that doesn't just hit a target, it solves a problem that once seemed impossible to crack. The HIMARS has fundamentally shifted the balance of power because it turned the vast, chaotic battlefield into a controlled, digital grid where there is nowhere left to hide. It is the definitive proof that in modern warfare, information is just as lethal as the explosives themselves. We obsess over these details because we believe that understanding the technology behind the headlines is the only way to truly see how our world is changing. Every animation you see and every technical breakdown we provide is created entirely from scratch by our small team of just 3 people. We spend weeks researching, fact-checking, and animating to ensure that these complex systems are as clear to you as they are to the engineers who designed them. Bringing this level of depth to a small screen is a massive undertaking, and your support is what keeps us going. If you found this deep dive satisfying, please like the video and subscribe to join our community of tech and military enthusiasts. But now, I want to hear from you. The world of military technology is moving faster than ever, and there are still so many ghosts left to uncover. What piece of machinery should we put under the microscope next? Is there a specific jet, a secret drone, or a massive naval vessel you've always wanted to see dissected? Let us know in the comments below. We read every single suggestion. Thanks for watching, and we'll see you in the next one.